Hey guys, welcome to another lesson on the GED 2019. So this section we have decimals and fractions on the number line. Not sure if you guys are familiar with the number line or not, but here it is. So here's a few key ideas. A number line is, let me change this real quick to the pointer. Okay, a number line is a picture that helps you compare the sizes of numbers. Numbers on the left are smaller than numbers on the right. Number lines can also be used to represent and compare decimals. Fractions and mixed fractions can also be represented on the number line. So here's the number line. As you can see, like it says, start from left to right, small to large. Okay, which is kind of contrary to, if, for example, if this was the decimal point right here before the 0, like we have the place values of the tenths, hundredths, thousandths, versus on the left of the decimal is ones, tens, hundreds, thousands, which in that sense numbers to the left are greater. But since this is a little bit different here, it just goes to the right. Greater is to the right. So on the GED mathematical reasoning test, you may need to recognize or locate fractions, mixed fractions, or decimals on a number line. A number line represents numbers in order from least to greatest. As you move to the left along a number line, numbers decrease in value as you move to the right. Okay, yes, we kind of got that. It's to the right, they're larger. Okay, the arrows on the ends indicate that numbers continue forever in both directions. Okay, if you imagine zooming in on a portion of that number line, it might look like this. So see here, they're counting in increments of quarters or 0.25, okay, or 1/4. So for example, this all between the 0 and the 1, imagine it being 0 and 1 here. And like they said, they're zooming in so you can see the increment of fourths going up, okay? So 25, 50, 75, 100, which makes one whole. Then same here, 25, 50, 0.25, 0.50, etc. And then it would be 2 after the 71.75. Thus a number line can include decimals and whole numbers. For example, the point represents 0.75, which is greater than 0.5 and less than 1. A number line can also represent fractions and mixed fractions in order from least to greatest. As you can tell here, they're all going from least to greatest. Okay, 1/4, half, 3/4, etc., etc. Okay, use this question to practice working with number lines. John works 5 shifts per week. His boss asks him to spend exactly half of his time this week working on a specific project. How many work shifts will John devote to the project? Circle the answer on the number line below. Okay, so if you think of half of 5, if there's not necessarily an even whole number for half of 5, which is what you need to do to resolve this problem here. If John works 5 shifts per week, his boss asks him to spend exactly half of his time this week working on a specific project. So we know we need to find the half mark. So for example, if it was 4, we'd know the half mark is 2, because 2 is half of 4. Okay, but 5 doesn't really have an even half mark, so we know it would be 2.5, because 2.5 plus 2.5 equals 5. Okay, as you can see here, if you circled 2.5, you are correct. Multiply 5 by half to determine that John will spend 2.5. So let's do that real quick. So let me exit this pointer here. Okay, well that didn't work. Hide screen brush. There we go. Okay, so 5 times 1. Actually, let's do this. 5, because we're going to have to make 5 into a fraction too. 5 times 1/2. Okay, need to make 5 into a fraction to make this problem here. So let's see. 5 times 1 is 5. 5 times 2 times 1 is 2. Okay, so 2 goes into 5 how many times? Well, it goes in there 2 times, and there's 1 left over. So we put the 1 up here, and we know we always put the denominator down here, so that's 2.5. Okay, so that's how to figure it out by working out the problem. Easy enough. Okay, so let's move on to the next page. Okay, so choose. This is number 1. Let me increase the size a little. Choose the one best answer to each question. Okay, so what is the value of the point on the number line below? Okay, so we're missing the point right here, or the value right here on this point. So you kind of want to look at the numbers around it, okay, and it's definitely helpful to be familiar with fractions to accomplish this. So we see 0, 1/3, that's missing this one, then 1, then again 1, 1/3. So if you're familiar with fractions, you will see here that they're counting by thirds. Okay, so you would know that this would be 2/3. Then you might ask, well, why is this not 3/3 right here? The reason is because 3/3 equals 1. Okay, so instead of putting 3/3 there, their fractions, they always want you to reduce to the simplest form, and 3/3 would be reduced to 1. So you would see 2/3 right here. Let's see, 2/3 right there. Okay, and that would be your answer. So they have an option. C is your answer there. Okay, what is the value of the point on the number line below? So again, how are they going up incrementally? Let's see, 2, 2.2, 2.4, 2.6. So they're pretty much going up by counting by 2's. In this case, 0.2. Okay, it's 0.2, 0.4, 0.6. So logically, this would be 0.8, 2.8. Okay, then the next count up from 2.8 would be 3, obviously, because you can't put 2.10. So D is your answer for that one. So again, look around you and see what they're incrementing it up by. Okay, if in the number line below, what is the value of A minus B? So A minus B. 3.5. You may be able to do this in your head, but we'll work it out on paper. 3.5 minus 1.5. Okay. So 1 minus 1 is 0 over 2. So this doesn't work. We don't need this. Anytime there's 0 over 2, then it's nothing, okay? So you don't even need to do this right here. Just simply do this. 3 minus 1 is 2. So 2 is your answer. Okay, so where were we? Yeah, so 3.5 minus 1.5 equals 2, which is the C. Okay, Angela baked 24 cookies and gave 16 of them to her neighbor. On the number line below, circle the fraction of Angela's cookies that she gave to her neighbor. Okay, so let me erase this here. So we know Angela baked 24 cookies total. Okay, let me move this over a little. We know she baked 24 cookies and she gave 16 of them to her neighbor. So we need to basically simplify this because this is the fraction already, which equals one of these here. But again, they want you to reduce this into lowest terms. How do you do that? You find the highest number that goes into both of these. You can't, if you can't think of the highest number, sometimes when these numbers get larger, it's harder to think of a higher number that goes into both of them. But for example, you know that 2 goes into 24 and 2 goes into 16, you know, if no for no other reason, just because they're even numbers. But then that would take you like a longer process along here to actually longer process all the way here to actually get it simplified. So if you find the highest one, then it's only one step. So I know 8 goes into 16, so division. Okay, anytime you're trying to reduce, you divide, okay? So 8 divided by 16, or you could say 8 goes into 16 2 times. 8 goes into 24 3 times. And this cannot be reduced any lower other than with the number 1, but that doesn't count because that means it is reduced to the lowest. Okay, so 2/3 is your answer. Right over yonder. Okay, let's see. Okay, number 5. Let me erase this first. Stay organized. Write the decimal value of the points on the number lines. Okay, same thing pretty much. Or not same thing, but as some previous ones is what I mean. So again, you can see it goes up incrementally here, so we have to figure out what it's counting by. So 125, when I first looked at this, it is a little confusing because like this has 3 numbers, this has 2 numbers here. So the reason this has 2 numbers, when I finally figured it out, I realized, hey, this is 250, and anytime you have a 0 as the last number behind a decimal point, it has no value. So you can remove it and the number would still be the same value. Okay, so 125, think of this as 4.125, think of this as 4.250, think of this as 4.375, think of this as 4.500 if you like. So we can see they're counting. This should be a good indicator right here because the very first one starts at, you can see here, 4, then 4, the next increment is 4.125. So we know they're going up 4.125 once you match it up also with these numbers as well. So they're bringing each one up by 0.25. Sorry, that point shouldn't have been there. Should have been in front of the 1. 0.125. So right there, it's supposed to be 4.625. Okay, because from 4.5 or 4.500 if you like. Remember 500, but you can remove both of the zeros since the zeros have no value past the decimal point. At least zeros that don't have another digit that is not a zero to the right of them. Excuse me. So 4.625. Okay, that's your answer for that one. Next one is number 6. Let me erase this. Excuse me, my throat's a little dry. Okay, number 6. Same thing. So 8, 833, 866, 9. So if you know your fractions, your decimal, your chart, decimal and fraction equivalent chart, so which means like this fraction here, or the decimal 0.33 is what it's equivalent to in fraction form. You know, for that particular one, it's 1/3. So the reason they have this line here is because this would keep on going 3, 3, 3, 3, 3. This is a number that does not terminate. Okay, but with the line over it, just lets you know instead of having to write 3's to infinity, lets you know that, hey, this 3 would keep on going. And this also is 1/3. Okay, this is 66 is double 33, or 0.66 is double 0.33. So what's double 1/3? 2/3. Okay, so instead of writing 8.99, okay, with the line across it, you know, we know that 3/3 is 1. Okay, anytime the number is same number, same numerator and denominator, we know that equals 1. Basically, say, instead of 8.99, it just went up to the next whole number, which is 9. So now it's starting again, counting by thirds. So the next would be 9.33 with the line on top of it, which means 1/3. So we know that this would be the answer. Okay, as you can see, next is 9.66, which is 9 2/3. Then you have 10, etc. So next is number 7. Write the fraction values of the points on the number lines. For each of the number lines below, fill in the value of the point using mixed fractions. Okay, so here we have 2. Okay, we're maintaining the fact that it's 2 over here, visibly. Okay, 2 and 1/3. Still 2. Then 2/3. Again, they're counting by thirds here, as you can see. Same as they're counting up here by thirds. Just this is in decimal form, this is in fraction form. So then we have 3, 3 and 1/3. Okay, so this is, sorry, it's supposed to be 1. 3 and 1/3 is your answer. Sorry, it's terrible 3. Using my mouse to write. Yeah, 3 and 1/3 would be the answer for that. Okay, now number 8, I'd say is the trickiest one. It's not that difficult. I would pause it, try and figure it out myself if I were you, just to kind of, because if you do that, then I explain it to you, then it kind of consolidates it in your head from trying to figure it out on your own to actually understanding it. So as you can see here, this 11, 11 1/6, 11 2/3, 11 and 1/3, 11 and a half, 11 2/3. So if you're not really conscious of what's going on here, it kind of doesn't seem to have any rhyme or reason, because like some of these ones over here, for example, 1 and 1/3, 0 to 1 and 1/3, skips that one, but then goes to 1, so in between here is 2/3. You can kind of see the progression. Whereas here the denominators are kind of different, and goes down, then it goes up, which kind of throws you off a little bit. But you have to remember that when in fractions, they're always reducing, okay, to the lowest terms. So, for example, here they're counting by sixths, 1/6, okay? And again, like I said before, the first one up can always be an indicator. Like when we looked up here at number 5, went from 4 to 4.125. So this one went to 11, 11 and 1/6, so we see that it's counting by 1/6. Okay, so, but it just, what it does here, if you can imagine this as 11, 11 1/6, 11 and 2/6, okay, 11 and 3/6, 11 and 4/6, and I'll show you what I mean by that. See this 11 1/6. So if you were to have 11, next one up is 11 and 2/6. If we were to simplify it, I'm showing you right now, if you were to reduce 2/6 right over here, you'd find the highest number. Remember, that goes into both of these. So 2 goes into both of these. 2 goes into 2 one time, and 2 goes into 6 3 times. So as you can see here, they right over here on number 8, they put the reduced form instead of 11 and 2/6, which logically you would think it would go there. They actually put the reduced form, which is, well, 11. Imagine an 11 right here. 11 and 1/3. Okay, then they did the same thing here. 11 and instead of 11 and 3/6, they put 11 and 3/6. To reduce that 3/6, they find the highest number again. 3 goes into both of them, so 3 goes into itself once, and 3 goes into 6 twice. So they put 11, they put the reduced form of 11 and 3/6, which is 11 and a half. Okay, so they're moving up incrementally by 1/6. So here would be 11 and 5/6, okay, because that 5/6 does not have a reduced form, so you go back up to having 6 as your denominator. So sorry, the 6 is really crappy. So that would be your answer for number 8. Okay. Trying to see if there's any other way I can explain that too, but not really. I think that's pretty thorough. Anyways, thank you guys for watching this one. Please like and subscribe if you appreciated the help. Share it with a friend who's studying GED as well. And thank you very much, and see you at the next lesson.